Now, in question number 7, guys, you can see the diagram shows a smooth track which lies in a vertical plane. Any A, B, C, E, this is a smooth track. There is no friction on it, and it is just like hanging in a wall. Yani I can see the motion is happening in a vertical situation or a vertical plane. So something is happening in front of you on the wall. Does it make sense to you guys? Because for modeling purposes, he has to do this thing and make sure that the motion should stay in a straight line. Anyways, the section AB is a quarter circle of radius 1.8 meters from the center O. So this is basically the quarter circle motion will happen when the body will be released from A. So this is a quarter circle, and the radius is given to us 1.8. The section BC is a straight line of length 7 meters. So this is a straight line segment, guys. BF is a straight line. And total BC, sorry, BC is 7 meters. And then he said OB is perpendicular to BC. OB, yeah, perpendicular because he just want to show the radius. And then he said that there is another plane, CE plane, which is making an angle theta with the horizontal. Now, the actual question starts here, where he mentions that a particle of mass zero point 0.5 kg is released at A. So it is going to be released from here. A particle P collides with the particle P collides with the particle Q of zero point 0.1, which is rest at B. So right now we need to focus at the motion from A to B. So guys, I'm going to consider the motion from A to B. The reason is show that the speed of q immediately after the collision is 10 meter per second. So since the collision is involved, we have to use the momentum and also we have to bring the energy in our mind. Whenever we see the body is moving on irregular paths, we have to consider energy equations. So energy equations tells you the body is moving from point A to B. So why not we can use the law of conservation of energy? The total energy at point A must be equals to the total energy at point B. So what was the kinetic energy at A? Since the body was at the position of rest, you were about to release, so your kinetic energy was zero. When it comes to the ground at point B, no, just try first consider what is the potential energy over there. The mass was zero point 0.5, the G value was 10, and the height was, since the body is here, so it means the height of the body will be 1.8. So we can easily find the potential energy of A. However, the kinetic energy at B, because at that time when it comes to the ground, the body will have some speed. So half times zero point 0.5 times V squared. And on the ground situation, you all know that potential energy will be zero. Now you can solve this equation and easily find the velocity of a particle P. Did you see, guys? I put P in the subscript. It tells me that I'm talking about particle P because there are so many other particles involved. So if you have multiple particles involved, so you may use letters to show in the subscripts of velocity, acceleration, to say that to make sure for the examiner or for yourself that which velocity or which quantity of motion you are talking about. Okay, so law of conservation of momentum I have to consider because collision was involved. So what was that? Before the collision, the mass was zero point 0.5 and the speed was because you remember that what is the momentum? The momentum is mv. So I need to understand when the particle reaches at point B, at that time, what was the speed? We have just found out the speed of particle P. I'm talking about this situation now. Now, because the collision is going to happen here. So what is the mass of the particle A? The particle A 0.5, and what is the speed? 6. What is the mass of particle B? It is zero point 0.1. And what is the the speed at that time? It was in the state of rest. So this is the total momentum of a particle before collision. So this is before collision. Now, I need to check what happens after the collision. After the collision, the mass of the body is of particle A is zero point 0.5, and as per the question, the body starts moving with 4 meters. The particle P starts moving with 4 meter per second. So I just wrote 4 here. Now, as I said, mass of B is zero point 0.1, and I want to find the speed of Q after the collision, and I put Q in the subscript of V. Then I solve this equation for VQ. I found out after the collision with the particle P, the Q will be moving with 10 meters per second. Now, all of you must be known that the particle P has moved from point A to B. Now they are collided. Particle P is moving with some speed, and also particle Q is moving with some speed. Particle Q, we found out, it is moving with 10 meter per second, and the particle P is moving with 4 meters per second. Now, go to the part B. When Q reaches C, it collides with the particle R. Look, the third particle is also involved, and which is rest at C. The two particles coalesce and they will join together. The combined particles comes instantaneously to rest at F. This is the inclined plane which he has made it. I'll show you in a minute when we go to the diagram. So we also assume that there is no instantaneous change in speed as the combined particles leaves C. Okay, at the C point, no change in speed. So yani the initial speed will become the final speed and in the next phase. So no need to for modeling purpose, this is the thing which examiner has mentioned, nor when it passes through C again as it returns down the slope. Now when I take you to the graph, so the C point, when the particle B will come and hits the particle R, can you check that I have written here Q plus R? So Q plus R at this stage, as per the question, both particles coalesce and they will go up. Okay, they will reach to the point F, and then they will come down, or maybe they will get back to the straight, path which is BC. But as per the question's instruction, the speeds will not be changed. Instantaneous speed will not change at point C, whether QR is going up or it is going down. Uh, Now, read the question which he's talking about. He said that given that the distance CF is zero point 0.4 and find the value of theta. So if I want to find the value of theta, again, I need to consider the law of conservation of momentum. Why law of conservation of momentum is required? Because I want to know when Q hits R and both particles coalesces, at the coalesce situation, when it just starts the journey on the inclined plane at point C, what was the speed? So here you go. You remember the particle B has a mass zero point 0.1, and its speed, when you guys saw that when particle P hits Q, after the collision, particle Q was moving with 10 meter per second on the straight path. So it is still 10. So before collision, the particle Q is moving with 10 and its mass is zero point 0.1. Before collision, you remember the particle R was having a zero speed, and it was rest, and its mass was zero point 0.4. So this is basically happening at the point C when the particle B is about to collide the particle R. So this is before collision, guys. Now after collision, what happens? After collision, both particles coalesce. So we added their mass. So now the total mass of both particles is zero point 0.5, and they have a combined speed, which is, I wrote here Q plus R, which represents both particles are together. Now they coalesce. So the combined velocity, the speed of the body is 2 meter per second. With this speed, it starts moving up the inclined plane. Now, on the inclined plane, Newton's second law comes in action. We want to know what is the deceleration because the body will be slowing down. Is there any force acting upward? No. What are the forces acting downward? The weight component, the mass times 10, and the sine of theta. So, this is the situation we have. An acceleration, the mass, the combined mass of the particles, and I want to find the deceleration. So, I found deceleration in terms of theta. Now, another important point, guys, as you remember, that he gave you the length, the distance which the body will cover along this inclined plane track, which was zero point 0.4. So, CF distance, I wrote it here 0.4, like this one, but zero point 0.4 should be this one, the CF distance. This is 0.4. Now, equations of motions comes in action as I have the speed, final speed. The body will stop at F and comes back. You remember, guys, we found out the both particles will go up with a speed of 2. So this was my initial speed. So 0 minus 2 squared, I wrote it here. That's why examiner mentioned that there was no instantaneous change in the speed. Acceleration, we found out zero point 0.2, and you can see now in this equation only theta is unknown, so I can easily find the value of theta, which comes to be 30 degrees. Now you can plug this 30 degrees back into the acceleration. You can find the value of acceleration. But as per the question in this part, what is the value of theta? We found out theta 30 degrees. So both law of conservation of momentum, Newton laws, and the equation of motion helps to solve this question and find the value of theta. In the part C, guys, he said, find the distance, and this is the trickiest question. Find the distance from B at which the P collides with the combined particle. This is quite interesting. You remember, guys, the at the point P when the particle P hits, okay, and also the particle yani hits with particle Q. So this is particle Q, and this is particle P. Now particle Q was moving with 4 meter per second, 10 meter per second, and particle P was moving with 4 meter per second. After a while, there is a point C here where a particle R is there. The particle Q reaches to this position and coalesce. It goes up to the point F and then it comes back. In the meantime, particle P was also moving. Supposedly, in this whole journey, particle P reaches to this point. Total distance was given by him 7. So examiner says that you have to find this distance which the particle Q will travel when QR comes down, and at some stage here on the horizontal track, they will hit each other. You get my point? So P, Q, and R, they will hit each other. We need to find, sorry, not this distance is asked by the examiner, this distance is asked by the examiner. When they all collide with each other. What a nice question the examiner has made for the students. But if you will work in phases, you won't have any trouble. Let's start. You have to label whenever you are working with different particles. So you can see in the question I have labeled particle Q. So particle Q motion from B to C, you all remember, I can use the constant speed equation for the distance is the distance covered from B to C is 7 and the speed was 10. I can find TBC time. TBC time means the which the particle Q takes from B to C. So zero point 0.7 seconds it will take. Now, I want to see how much, the time the Q particle will take from C to F. Okay, now C to F, if you guys can see, we have final speed 0 and U is equals to 2. Got it, guys? U is equals to 2 because at this situation, basically they coalesce. So I must call it as from C to F as Q plus R. That's better. And we also found out what was the deceleration. I substitute the value of theta, which was found 30 degrees. I substituted here and I found the deceleration is minus 5. Now I want to find how much time the coalesced particles Q and R will take when they are going up. So they are taking 0.4 second up. For sure, they will take when they will come back from F to C, they will take again 0.4 second. So why not I can find all the times from B to C, yani the particle, let me explain you, the particle Q from here and here it becomes Q plus R, it goes here and then it comes back. So this T1 time, this is T2 times, and this is T3 times. So I just want to add all the times. So when I added all the times, so 1.5 seconds the Q particle will take starting from B, reaching to C, C to F, and then F to C. B to C, C to F, and then F to C, how much time will be consumed for particle B and then coalesced with particle R to come back to C. That time is 1.5 second. For sure, I want to look at particle P, how much distance traveled by particle P in this 1.5 second. Definitely, it will be on the straight track. So I will use the constant speed formula for distance. You guys can see that the BF distance, so Mr. Omar is saying here, BF distance is, can you check that? This is the BF distance which the body will, particle P will cover in 1.5 seconds. So I want to check that. So guys, if you can see, I have found BF distance 6 meters. So the total distance was 7 meters. So now how much distance is left between them? It is 1 meter distance left. So we have made the question very simplified that after spending 1.5 seconds, the particle P is here and particle Q plus R is here, and they are ready to collide at some point. And we know the total distance between them is 1 meters. Suppose this distance is x, so this distance will be 1 minus x. Got it? Now we will consider both particles separately and we will use the equations of motion to see that what is this x and how much time they will take to hit each other. So let's see what happens. As you guys can see, let x be the distance covered by P from F to G, and G is the collision point, guys, where they will collide. So XFG, I said FT, okay, because the speed, you remember, after P hits Q at point B, it was moving with 4 meter per second, so it stays the same. So for it, I say that it will take T time from F to G. So I found this time as xfg over 4 because I am interested in xfg distance. So that's why I found time in terms of xfg. Obviously, then 1 minus x will be the distance covered by q plus r from C to G. So can I use again the equation of motion? 1 minus xfg is equal to 2t. Why 2, guys? Because 2 is the speed of the particle q plus r when it is coming back from point C. So now I'm ready to substitute the value of t here because time will stay the same in both particles p and q plus r. So let me put it here, q plus r, guys. Okay. So this gives me xfg distance 2 over 3 meters. 2 over 3 meters. And I want to find how much distance the particle P has actually covered. You can see this was B, this was F, and this was G situation. And that was the x distance. We found out that the particle P will cover 6 meters distance from here to here. And just now, in the last phase of the question, we found that x is 2 over 3 meters. And this particle from C to G will cover 1 over 3 meters because the total distance was 1 meters. And we found out that total distance was 7 meters from B to C, right? So let's move to the the question which he's talking about. It got stuck. Let me just do this.